Welcome to Subtheme 2 about farm and ecosystem level benefits of conservation agriculture systems to farmers, society and environment. My name is Søren Ilsøe and I'm from Denmark, and I have the task to be chair of this session. I'm really happy to have you all here. And in this session, we are going very far geographically, so it will be excited to hear all your new informations. Our first speaker is Mr. Imran Jumshudov. He is director of the Center of Agrarian Science and Innovation in Azerbaijan. And the line is impact of conventional soil tillage and raised bed cultivation method of growth of winter wheat varieties. Welcome, Mr. Jumshudov. You can start.
Good day, everybody. Impact of conventional soil tillage and raised bed cultivation method on growth of winter wheat varieties. Towards a more sustainable crop production in Azerbaijan. Increasing wheat production for reliable food supply in Azerbaijan is one of the main targets of the government strategy. Country's national development concept for near future intends to boost agriculture productive capability through application of modern technologies. Grain production is a grand pillar of agriculture in Azerbaijan, where the wheat demand ranges from 3.3 to 3.8 million tons annually. However, the overall demand is not completely met with the current yield and production rate. Raised bed cultivation method as a remarkable way to reduce soil erosion and ensure soil fertility. The field experiments were conducted at Tartar Regional Experimental Station of the Institute of Crop Husbandry. A 2-year field study was conducted during 2010 to 2011 and 2011 and 2012 crop season at the Tartar Regional Research Station located in Tartar district to determine the effect of conventional soil tillage and raised bed cultivation of wheat on growth characteristics of local winter wheat varieties. The effect of different tillage and sowing method on growth characteristics of plant. Seeding emergence. The results show that the seeding emergence percentage was not significantly affected by the tillage treatment during both the wheat growing season. Maximum seeding emergence percentage was noted under raised bed treatment. There was not significantly linear and quadratic response in seeding emergence under various tillage treatment during the study years. Growth. Effect of tillage treatments on number of roots, root length and root dry year. As can be seen from the table, the maximum number of roots at the depth of 0 to 10 centimeters was observed in the treatments in 2011. In addition, it was found that the number of rows in the raised bed tillage system at the depth of 0 to 10 centimeters was 2.4% greater in the first study years and 2.2% greater in the second study years compared to the conventional tillage system. Spikelets per spike. Effect of different tillage treatments on number of spikelets per spike, spike length, and number of grazing per spike. The result indicated that the number of spikelet per spike was significantly affected by tillage treatments during the birth years. The great number of spikelet per spike was observed under raised bed tillage, and the number of spikelet per spike declined under conventional tillage during both 2011 and 2012 respectively. Number of grain per spike. The results show that the number of grain per spike was markedly influenced by tillage treatment during the birth study years. Maximum number of grain per spike was noted under raised bed tillage, while this number declined under conventional tillage. The comparison between two study years shows that the number of grain per spike during 2012 was greater than 2011. Economic analysis. Economic analysis shows that the winter wheat variety Azamatli 95 gains the highest economic profitability under conventional soil tillage with seed rate of 117 to 118 kilogram per hectare, fertilizer rate of nitrogen 120, phosphor 19, and inter-row space of 50 centimeters. Under raised bed cultivation technology, this variety gained the highest economic profitability with nitrogen 120, 19, fertilizer rate, and 130 to 140 kilogram per hectare seed rate. Tale 38 winter wheat variety gain has economic profitability under conventional soil tillage with 117, 118 kilogram per hectare seed rate and nitrogen 120, phosphor 19, fertilizer rate. The highest economic profitability of this variety under raised bed technologies was 247.3% with 130 to 140 kilogram seed rate and nitrogen 120, phosphor 19, fertilizer rate. Conclusion. Compared to conventional tillage, raised bed cultivation method caused substantially improvement in almost all growth yield and yield compare traits of winter wheat varieties. Particularly, it improved seeding emergence percentage, plant height, root system, number of main stem leaves per plant, number of productive tillers per plant, number of spikelets per spike, spike length, number of grain per spike, grain and sow yield per hectare. Growing wheat on a raised bed with 16 to 17 centimeters, wide is first step to adapt no-till technology and the irrigated farming system in the country. With seed rate of 130 to 140 kilogram per hectare and fertilizer rate of nitrogen 120, phosphor 19, winter wheat yield increased to 6.91 ton hectare by using the planting method, when it was 5.95 ton per hectare under conventional tillage method. Most of the farmers apply conventional methods such as flat planting and flat irrigation that has high water consumption and leads to soil erosion. By applying the planting method, which is the second stage of resource conservation technology, it is possible to reduce the seed rate, fertilizer application, and water. Thank you for your attention.
Thank you very much for this information about growing winter wheat in your region. I have to say to all the viewers that you can write your questions, and then in the end of the session we will try to go through all the questions and get some answers. The next speaker is Mr. ML Jat. Mr. Jat is a principal scientist and agronomist who coordinates research on sustainable agriculture in maize and wheat-based systems across Asia. Welcome, Mr. Jat. You have the word. Thank you.
Thank you so much, Mr. Chairman. Thank you, Mr. Chairman. Rapporteur and fellow participants, good morning, good afternoon, good evening. Thanks to the organizers for this opportunity to share some of our work on conservation agriculture impacts in cereal-based cropping systems of South Asia based on our meta-analysis. We all know that South Asia has unparalleled challenges. And when we talk about challenges, the first thing is the population, because it's one of the densely populated regions, having 1.7 billion people, and by 2050, the number is expected to grow to 2.4 billion. It's also a global hotspot for contemporary and future climatic variability. The region has, 3 to 5 times higher pressure on the natural resources than the rest of the world. And we need more nutritious food from less and moreover from the degraded natural resources, and having the projected climate change impacts. And also you can see in this map, the region is dominated by very smallholder farmers, and Asia's 450 million smallholder farmers produce about 80% of the food consumed in the region, and that shows the importance of the smallholder farmers in the region. So the conservation agriculture in smallholder farmer systems of South Asia is very much important. And if you talk about agriculture's contribution to sustainable development goals, that requires climate smart, regenerative and profitable technologies and institutional innovations. Also, there is attention on conservation agriculture as a strategy of sustainable intensification, but there is a lack of evidence-based consensus on merits of conservation agriculture in the smallholder systems of the region. So with this background, we did a meta-analysis of conservation agriculture using some 10,000 paired side-year comparisons representing different indicators of the cropping system performance. When conservation agriculture practices are compared, separately or in tandem. So with this, we used different set of treatments, for the comparison purpose. One is business as usual, which is conventional tillage-based systems, residues retained or burnt or incorporated or removed, and it's a double cropping system. Also, zero till in one of the crop in this system, or zero till in both the crops in this system, with residues retained with the double cropping system, or no till or zero till in all the crops with triple cropping systems with residues retained in at least 2 of the main crops in the system. And using that, we did meta-analysis at 2 stages. The one with the conventional and conservation agriculture practices compared, and the stage 2 when conservation agriculture was further classified into 3 categories and compared with the conventional system as a control. So the overall performance of conservation agriculture in South Asia indicates that, if you talk about on-station trials, there was a yield gain of nearly 12%. Same is the case for protein equivalent yield. There was a gain in water use efficiency up to 30%, and also the net economic return more than 25%. Whereas in on-farm, in data, the yield gains were something like 6-7%. The water use efficiency was higher by 10%, and economic returns were higher by 25%. Whereas if you put together the on-station and on-farm data, the yield gains were something like 6-7%, and the water use efficiency was higher by 15%, and the economic returns by 27%. If you talk about the cropping systems response to conservation agriculture for yield, for water use efficiency, and for economic return, you can see that some cropping systems are more responsive than the other cropping systems, and the case is like maize wheat system is more responsive in terms of grain yield and the water use efficiency than the other cropping systems. But in terms of the net returns, you can see the rice wheat was more responsive because rice wheat is, having intensive tillage, a lot of labor, a lot of energy requirements. So there is a significant reduction in the cost of cultivation in rice wheat system. But overall, the returns were higher, ranging from 20 to 30%. If you put together, the percent change over control in terms of the grain yield, the protein equivalent yield, the water use efficiency, and net economic return, whether you use one element of conservation agriculture or all the elements of conservation agriculture, there has been a significant increase in all the parameters. Conservation agriculture with no-till in a double or triple cropping systems with residues retained or removed still has advantage, in terms of yield, water use efficiency, and economic returns. But those response varies from, with the cropping system. In some systems, there are more gains. In other systems, there are less gains. And you can see in terms of the productivity in maize wheat system, there are more gains compared to the rice wheat system. And also in terms of the economic returns, you can see those variations. Also, the response of conservation agriculture varies with the soil types. And you can see yield and water use efficiency. The grain yield was, highest in moderately fine soils, whereas the water use efficiency was highest in the clay soils. So it depends what parameters you are looking and what soil type. But in general, medium textured soils are better, responding to conservation agriculture in terms of yield than the other soils. Now, if you put together all the 10 culture in South Asia's smallholder systems, from the perspective of the systems yield, 5 to 12% increase, 10 to 30% increase in water use efficiency. There is a significant saving in labor, ranging from 26 to 44%. There is a significant saving in energy, ranging from 46 to 62%. And the profitability increase was 20 to 27%, which is quite substantial, quite significant. And of course, the reduction in the global warming potential or greenhouse gas emissions ranging from 12 to 33%. So from all those parameters, conservation agriculture is benefiting. Now, this all information has been published in this paper in Nature Sustainability. If somebody is interested, can have a look on this paper, and this indicates that there was more favorable response of conservation agriculture in loamy soils or medium textured soils, and also in maize wheat system compared to the other cropping system. The results also suggest that there are opportunities to maximize the expected benefits of conservation agriculture, but the policymakers and development practitioners should continue to be appraised of potential of conservation agriculture, contributing to the sustainable development goals in the region for which we all are committed to. And you can see that conservation agriculture directly or indirectly contributing to these 10 sustainable development goals, which is quite significant. Of course, there are certain barriers of adoption of conservation agriculture, which also I would like to share with you. The one, in this predominantly double or triple cropping region, still the conservation agriculture is crop or commodity centric. There is a lack of systems approach in conservation agriculture, whereas conservation agriculture is systems, focused. Still, there is a production focus. There is a lack of multi-criteria analysis from conservation agriculture. So just people are looking at the yield, but I think there are other tangible benefits as I shared with you. There is something missing in terms of the theory of change at different levels, whether it's subnational, national, or regional. And of course, knowledge and capacity gaps are still there. And conservation agriculture is a knowledge-intensive process that needs new knowledge, new capacity for its local level adaptation. People feel like it's a silver bullet, but it is not. So I think we need to have local level adaptations, and that needs clearly a right targeting and defining the recommendation domains of the conservation agriculture systems. From the investment perspective, I think many a time it seems like that they feel like one size fits all, but that's not the case. I think there is a need, for policy, and more particularly from the perspective of lack of science. There is a lack of science evidence-based targeting and investment. So I think policy has to do a lot on this. Also, the social and communication is something very, very important from the perspective of conservation agriculture, because there's a lot of apprehensions, a lot of perceived risk versus the reality check. I think we need to have the reality check, should not be depending on apprehensions and the perceived risk. We need also a common neutral platform for learning and capacity, and for collective wisdom and action on conservation agriculture, which is limiting the adoption of conservation agriculture. But our analysis is contributing to some of addressing some of those barriers, especially from the multi-criteria analysis and investment perspective. So with this, thank you so much for your for time and attention. I'll be happy to respond any of your query, concern, and I'll be happy to have your suggestions to improve. Thank you so much.
Thank you very much, Mr. Jat. It was extremely interesting to hear your results, and very impressive results of conservation agriculture in South Asia. It is really a task to get the food supply up in the future with these climate changes. Thank you very much. Our next speaker is from Finland, Mr. Jussi Jaakko. And Finland is one of the countries in Europe that had the highest part of no-tilling, as far as I know. Maybe it's Spain today, but Finland was one of the front-running countries. And Mr. Jussi Knaapi is farming. He is also a journalist writing about agriculture, and he has also been involved in research. So, Mr. Jussi Knaapi, welcome, and you have the word. Thank you.
Ladies and gentlemen, I'm Jussi Knaapi, a Finnish agronomist, and will present no-till versus inversion practices to you. This is a long-term trial run by Konevietti magazine and working group, and it takes place in southwest Finland, Novira Farm School. We basically compare three different no-till methods shown here at left versus inversion systems based on plow culture or different mintills. And the area is described here inside the red dot lines. We also measure several things on top of the regular agronomy matters. And they are like weather and emission issues, soil-related factors, drainage water quality, and also nutrition questions there, maybe emissions. And spectral imaginary is part of the agronomy, plus all is based on soil scanning done by Veristic system. So we want to study here at left corner how we may stay profitable, what are soil structure and health issues, how nutrition and agronomy goes, yield and quality of yield. We want to minimize environmental footprint, and of course, carbon sponge or carbon sink is very important. Yeah, we actually try and do a normal agronomy based on half-hectare plots, and rotation is shown here, which is really a good rotational practice. Here we see different managements and how they relate to yields. So a yearly yield is 100, which is an average number, here a black line in middle. And each method here in this graphic, which is simplified, is shown like a red line is no-till, those three methods. Brown dotted line is autumn plow, and then these violet and gray lines are min-tills. And years can go from 2006 to 2020. We also separate weather occasions. A critical period, May and June, the rain event millimeters are shown here. And these blue areas actually show the very high rainfall events which take place at early summer. And opposite low rainfall is yellow, which is very, very low rainfall. So they are extremes. And if we look at the graphics, we actually see that no-till, the red line, can produce safe yields also in high rainfall events, opposite to inversion, but also at the extreme drought, no-till has been the best compared to inversion systems. We also know that there are issues always learning. Like 2015, we had an extremely heavy winter rice straw. So 2016, we had issues how to keep the drilling depth good. And this is why we got little failure there. But we wanted to show that also in the graphic. 2017, we had extremely good yield or no-till, but due to cold season and little happenings with extreme rain events at autumn, we managed to get the harvest done, but with a lesser success with the amount. We had a high harvest losses, but they are shown here to pinpoint that no-till also can be can have some risks how to manage it. When we go over to soil organic matter, we started 2006 with a visual normal laboratory assessment, and 2013 and on that, from 2013, we also measured the real loss of ignition. 2017, we started to do 3 depth loss of ignition measurements from 0 to 90 centimeter. So we actually have the 3 horizons, A, B, and C, down to 90 centimeter, and numbers out of those measurements. Carbon estimate is done by using coefficient 0.58, and bulk density is included to these figures. Here in the middle, we see on the left side soil organic matter averages on our trial field. And we can say that no-till actually has the highest organic content on top layer. This is 0 to 20 A horizon. Min-till is slightly less, and plow system even less than that, which is actually a natural thing. Here on the right side, we are seeing, we see the zones of these same fields, and the zoning is done by varieties scanning. So here we see that the average numbers are same what comes to the soil organic matter, but inside each parcel we have zones. So we need to know where those zones are and do the follow-up measurements accordingly. And here in the gray area, we have these 3 horizons, A, B, and C. We take the samples with the Danish Wintex sampler, and average organic content percentage are shown here in the middle, and we have converted those numbers to soil carbon numbers. We are very, very conservative now and give only slightly underestimated carbon sink numbers, but still, the effect over 50 years, each year has been quite high. So A horizon, the top is over 200 kilo, middle 300 kilo per hectare per year, and deeper subsoil even more, 450 kilo per hectare per year. So altogether, there really has been a considerable carbon sink effect. So conclude, soil organic matter actually has stayed pretty constant on plow systems because this is very tight clay type soil, so it doesn't oxidate away easily. In no-till, soil organic matter has risen clearly, and carbon, of course, but we need to have precise management protocols and measurement protocols to measure the carbon accumulation numbers. So we need to have exact coordinates, and they are really extremely important to get the reliable outcomes. We have a centimeter accuracy on our measurements. And international standards for carbon measurements, they really are needed, and we wish we could get this kind of international standard so that we could start carbon trade accordingly and get the best outcome. We have been using new measurement techniques on our site, and we'll continue and develop those continuously. We divide the areas to air, water, and soil. What comes to the air emissions, fluxes, we are testing our own idea of farmer eddy with 3 CO2 sensors in normal, regular farm weather stations. Also, some other measurements are under the soil, the soil properties. Then we pilot the carbon flux analyzer, a Finnish novel spin-off company with the flux analyzer. And we also have got some experience of a more advanced FTIR analyzer with several greenhouse gases. It's a Finnish company as well. Drainage water metering is part of the progress this year. So we are going to get the water flow and nutrition status from now on. And soil health is extremely important. And we've been using American Solvita Health Suite and also American microbe tests to analyze soil health and microbiological balance between bacteria and fungi. So conclusions are, no-till really has been economically viable over the years, return of invest questions, and so on. We are happy with that. No-till can increase soil organic matter compared to inversion methods. This is absolutely clear, even that we don't have really cover crops or grass lays. This is a combinable crop site, at least so far. Yield level has increased in heavy clay type soils as we have, and in soils which are drought prone actually. Environmental emissions are in check, and they are actually method based more how we do, not really, I mean, the management is the main thing. Excuse me. No-till has increased the resilience and improved aggregate stability that we have clearly measured. But in no-till, we need to consider that we are up north and we might have some issues with climate, with straw amount, etc. So we need to give special attention also to no-till technique. This is my conclusion to this trial. Thank you.
Thank you very much, Jussi Knaapi. It was really interesting because the discussions about carbon sequestration has been here in Denmark that there are no increase in soil carbon in the whole layer down to 90 centimeter. And your results are really showing that it is possible to raise the level of carbon in the whole soil profile. It's really interesting. Thank you very much. Okay, the next speaker is Daria Göllnitz from University of Bern in Switzerland. And we are going to hear about soil moisture suction in no-till and tilled soil, analyzing long-term tensiometer measurements in the Swiss Central Plateau. Welcome and thank you for joining us, Daria Göllnitz.
Hello, everyone, and welcome to my presentation. I'm Daria Göllnitz, and I'm really happy to present you today our long-term research about soil moisture suction in agricultural soils. So let's get started right away. As you can see in the subtitle, we analyzed a long-term data set. And when I say we, I mean the authors that are listed here below. We are a mixture of researchers from the University of Bern, the Soil Conservation Office of the Canton Bern, and Agroscope. Soil moisture suction is the force that is necessary for plants to extract water from the soil. Generally, we can say that in a dry soil, soil moisture suction will be high. Soil moisture suction not only depends on the water content in the soil, but also on other soil parameters. Now, what does this have to do with soil conservation? The wetter the soil, the higher is the risk of irreversible subsoil compaction. You can see here in the image that the wheel load carrying capacity, so the ability of a soil to withstand a certain pressure without being irreversibly compacted, is dependent, among other factors, on soil moisture suction. In our research, we wanted to find out if seasonal soil moisture suction fluxes would differ between differently managed soils. We analyzed 6 different sites in the Canton Bern in the Swiss plains, and Switzerland in general is situated in a transition zone between humid oceanic climate and continental temperate climate. On each of these 6 sites, at least 2 differently managed locations were present, and at every of these locations, 5 tensiometers were installed, which measure soil moisture suction at a soil depth of 35 centimeters. Before we get to the results, I want to present you the methods that we applied. Firstly, we qualitatively validated the tensiometer data because these measurement instruments do not always work properly. And after this, we ended up with almost 23,000 different measurement days with an available soil moisture suction value. We limited our research to the vegetation period from April to October, and we performed spade tests at all the locations that were analyzed. Also, we did a weather and climate characterization of all the analyzed years. Both of these methods were chosen so we would have a good interpretation framework for the soil moisture suction data. Finally, with the soil moisture suction data, we performed a lot of descriptive statistics and ended up with over 1,000 different plots, some of which you will see later. First, now I want to start with the results of the spade tests. What we can see here are 3 differently managed soils, and these spade tests were taken all really closely to each other. So the climate is exactly identical, but we have 3 different management systems applied here. We can see clear differences in soil properties just from looking at these spade tests. For examples, we can see iron concretions in the middle spade test, which is from the moldboard plow, which we cannot see in the right spade test, which is from the permanent grassland. Now we are moving on to the analysis of soil moisture suction data. And the first finding I can present to you here is that wet soil conditions in general are frequent. Wet soil conditions here are defined as soil conditions with lower than 6 centibar of soil moisture suction at a soil depth of 35 centimeters. And these have been found to really inhibit a high risk of irreversible subsoil compactions. We also found that these soil conditions can, in extreme cases, even persist for longer than 3 months. So this would implicate difficulties in agricultural management because probably as a farmer, we could not wait for 3 months until we traffic our fields. However, if we think again about the image that I showed in the beginning, we are here not talking about the wheel load carrying capacity in total, but only about soil moisture suction, which is one important factor for it. This is also kind of the limit that we have in our whole research, that we're never actually calculating the wheel load carrying capacity, but we are only analyzing soil moisture suction itself. However, we can of course still draw some really interesting conclusions about this parameter. What we can see here is that there's a strong seasonal curve in wet soil conditions frequencies. The frequencies of wet soil conditions are a lot higher in April, May, September, and October than they are in the summer months. The seasonal curve in soil moisture suction can be related to norm temperature, as we can see it here. If temperatures are high, evapotranspiration rates are high too, and therefore wet soil conditions are less frequent. The results that you see here are aggregated over different years and sites. Now, if we move on to only single years soil moisture suction fluxes, the picture changes. You can see here soil moisture suction fluxes of different sites, separated by color, and of differently managed locations per site, separated by line style. We find that differences between different years are big, and also differences between the sites are big. Sometimes we can see that management systems also seem to really influence the soil moisture suction fluxes. But in general, over the whole data set, it is not really possible to find a systematic pattern of difference between the differently managed locations. In the next slides now, I will show you some explanations why this was not possible and what the influences could be that determine soil moisture suction fluxes most. First of all, even if these two pictures before might have seen randomly, we can find that they are influenced by the weather conditions. You can see here temperature and precipitation anomalies for the 2 years. And for example, in 2014 in July, there was a huge positive precipitation anomaly. And at this time, soil moisture suction fluxes drop at all sites simultaneously. Second of all, we have an influence of different crops. What happened here is that in June, the winter wheat that was planted on the 2 crop rotation locations has a higher water use than the permanent grassland on the other location. After winter wheat is ripe, around July, this curve drops again. And what happened in Oberacker after winter wheat was harvested is that a new grassland was sown there. So here in the beginning of August, I think that this grassland was just still growing. So these plants do not need a lot of water, but then they start growing again, and the soil moisture suction on these locations reaches a similar level as the one of the permanent grassland soil, again around September. We also tried to find differences between no-till and moldboard plow. However, if we look at many different years here, just some randomly selected ones, it's really hard to find systematic patterns. As I said in the first slide with the first image, the wheel load carrying capacity is also influenced by other parameters. And here it's not even only just a thought, but we can actually prove that soil structure is changed through the way that we manage our soils. So even if we did not find a systematic pattern of difference between no-till and moldboard plow, we would still strongly assume that the wheel load carrying capacity of the 2 soils would differ. We are already reaching the conclusions. So what we found with this enormous data set is that in general, wet soil conditions are frequent, that they have a clear seasonal curve, and that they're influenced by weather. Furthermore, we could prove for some crops an influence of crops' seasonal evapotranspiration rates. In general, though, there are big differences in soil moisture suction fluxes between different sites and different years, and therefore we really want to stress the need of long-term research. As an outlook, I would like to propose to you to model soil moisture suction, or in general the water balance in soils across different soil depths. We really think that this would open up some really interesting research perspectives. If you want to know more details about the research I just showed here very briefly, I would be very happy if you read our extended abstract. And of course, I will also be happy now to answer all your questions live. Thank you very much for your attention.
And we also thank you for the interesting information. It surely shows that soil is a very complex thing to work with, but it's so great that you have the Oberacker plot, which is, I think, the longest no-till plots in the whole Europe. For many, many years it has been running now. So very interesting. Thank you very much for an interesting presentation. And the next speaker is Moussadek Rachid from Morocco. Mr. Moussadek is a senior specialist in soil and cropping systems. And during his 20 years career, the main topic of his research was related to soil and climate cropping system and soil fertility mapping and management. Also soil carbon sequestration in conservation agriculture in relation with climate change. This is really important in this time where we have a lot of focus on climate. Welcome to you, Moussadek Rachid. We are very interested listeners.
Okay, thank you, Mr. Chairman. The title of my presentation is Mid and Long-Term Effects of Conservation Agriculture on Soil Organic Matter, Physical Properties, Biological Activities in rainfed Mediterranean Soils. I present this in behalf of colleagues from INRA Morocco and also from ICARDA and University Mohammed V. First, we have to notice that in Morocco, we are a mainly cereal-based system. In fact, we have more than 80% under monocropping, but also around 5 million hectares under cereal. One big problem that we face in Morocco is the quality of soil. In fact, we have more than 50% of our land are under degradation. And also, last study on soil organic carbon, where we samples more than 40,000 samples in the country, but soil organic carbon was ranged between 0.5 to 1%, which is too low, and explain why you have this high degradation in our land. So we suggest, could we shift from this degradation situation if we adopt conservation agriculture, or could conservation agriculture enhance soil quality and productivity? For that, we set up two experimental trials since mid and long term, one 40 years and another one more than 32 years, since 1980. A trial consists on two tillage systems, one on no-till without disturbing soil, and another one under conventional system, which are adjusted. We try to adopt the same practices as farmers under conventional tillage, but under NT, except that covering soil with stable, 30% of stable, we did the same other management in both systems. The site, it's in the central Morocco, one in the region of, around the region Rabat, and another one near the region of Safi. The soil is virgin soil, but as you said, in the climate condition, we have one which is semi-arid, more than 300 millimeters, and the other one semi-arid to arid, which is less than 300 millimeters, around 250 millimeters. So for the method that we used for this study, we focus mainly on soil organic carbon, humic acid parameters, aggregate stability, and for that we use the method LivinGro, and soil enzymatic properties, mainly some parameters like alkaline phosphatase and aryl sulfatase, and also double-strand DNA. The main result, first, concerning the soil organic matter, we observed that under the midterm trials, the organic matter under NT or under notill is higher compared to CT, but mainly in topsoil, around 10 centimeters. And we find that it's more similar in the deep soil. For the long-term one, we observed that in fact the organic matter are more higher than in conservation sites than under the conventional system. But also we observe that it's mainly for around 0.6 centimeter, which means that for at least the whole profile, we observe this high amount of organic carbon compared under CA compared to conventional system. Another parameter that we measured is the humic acid, and we find that it was higher under CT, under conventional, under conservation system compared to conventional system. And this is this humic acid. Normally, they will lead to have positive effects on aggregate stability, which normally we measure it also in these trials. And we find it higher under CA. As you said, this is the main weight, the diameter, that an indicator for aggregate stability, and except mechanical disaggregation, but under rapid imitation and slow imitation that show the effect was higher and aggregate stability is higher under no-till compared to conventional system. But for the long-term sites, all tests under CA were higher compared to conventional system. Concerning the enzymatic activities, in fact, we try to say how the biological activity in the soil, and by extracting the double-strand DNA, we find that it was higher, 35 units more than conventional system, which is only 12 units. For alkaline phosphatase, also it was higher under no-till compared to conventional system, and it was 133 units higher than conventional system, which is only 30 units. For aryl sulfatase, also we find it higher under no-till compared to CT. But for leucine aminopeptidase, it was similar in both systems, which means that there is no difference between the two ecosystems. By this, we come to these conclusions. In fact, the study attests that the adoption of conservation agriculture can sustain the soil and enhance soil organic carbon quantity and quality under this dry condition while we were in mid or long-term CA sites. This study also showed that positive effects if adopt no-till system on soil biological enzymatic activities in this semi-arid Mediterranean conditions. But unfortunately, more effort is needed to promote the adoption of CA in Mediterranean zone to shift the land degradation and to reduce the loss of soil biodiversity. As you say, in this south part of Mediterranean, the adoption of CA still need to be promoted. And for that, more effort by the community and by scientists should be done to enhance the adoptions. Case of Morocco, we are now around 20,000 hectares. We need to promote this technology for more than this, and we can shift this land degradation in coming future. By this, I come to the end of my presentation. Thank you, and I thanks also for all participants and all projects that help us to find this result, mainly with ICARDA and INRA, and also another European project called KAMA, which is EU project that we just started last year, help us to collect some data on this field. Thank you.
Thank you very much, Mr. Rachid Moussadek. It was really interesting to hear, and especially that you have so long-term trials, up to 32 years. It's really impressive. And also, it's very nice to hear that you also have good trial information about carbon sequestration in Morocco. It's important in the climate debate to show that conservation agriculture can really make a difference. So thank you very much. And our next and last speaker is Javier Peris. He has studied biological science in the University of Valencia, and he has also continued to complete his doctorate in biodiversity and conservation. And since 2014, Javier has joined Syngenta Crop Protection, where he is working right now. Welcome, Peris, and we are excited to hear your presentation.
Thanks, Søren, and hi everyone. I'm Javier Peris. I work at Syngenta, and I'm going to talk about LivinGro. I don't know if you can see the screen because I just have the picture from Moussadek.
Yeah, same here. Now we can see.
Thank you. So yeah, I'm going to talk about LivinGro. And LivinGro is a pilot project to prove that modern agricultural technologies and biodiversity can coexist. But in order to understand the reason of LivinGro, we need to pay attention to the huge number of publications and news talking about insect and biodiversity decline, where we were able to read highlights like the insect apocalypse is here, or biodiversity is seriously threatened, or 40% of insect species face extinction in decades, and the massive decline in insects will have catastrophic consequences. It's clear that there are many reasons for this biodiversity decline, and unfortunately, agriculture is one of them, because during the last decades, there have been significant changes in agricultural practices, where we moved in the beginning of the last century with the small fields with high biodiversity to the large fields with low biodiversity currently now. As also, they have poor crop rotations with a high intensification of the modern mechanization. And even, as you can see in the pictures below, currently we have a large fields with no weeds where it's only one crop, and we are decreasing this crop diversity. And even we are losing the structural elements of the habitats because there are no trees, no margin, no shrubs, and all these changes are declining biodiversity. However, all of us, we know that biodiversity and insects are very important and are the key for the conservation agriculture, because insects are the key for the functioning of these ecosystems, and 80% of the plants depends on pollinators for reproduction. And that means 35% of the whole agricultural production. And if we extrapolate that in terms of money, we are talking about 265 billion euros per year. So for all these reasons, and because the importance of ensuring this conservation, Syngenta launched LivinGro. LivinGro is an R&D biodiversity pilot project whose main objective is create scientific field data to prove that modern agricultural practices and biodiversity can coexist. And we are going to develop a scalable protocol optimal conditions to enhance arthropods and microbiota biodiversity and contribute to securing crop yield, and also demonstrate how growers will get return of investment from these biodiversity measures. And for that, we are using what we call multifunctional areas, which are a mixture of plants and flowers that we use, for example, in the case of the field in stone fruits, like planting in the interrow area, or in the case of the wheat picture, where we have in just in a margin. But even in the large fields, we are creating bridges just to create small areas to enhance biodiversity. And this project is developed in vertical and row crops. In vertical crops, we currently have 24 trials in Spain and Chile, where we are looking at olives and grapes. And in the row crops, in Argentina, Germany, and Mexico, where we have 80 trials, we are looking in corn, oilseed rape, soybean, sugar beet, and wheat. And in all these trials, we are studying the impact of modern agricultural practices on the entire agricultural ecosystem, because we are looking into the field, into the multifunctional areas of biodiversity measures, but also in the surrounding vegetation of natural areas, because it's important to consider all these areas as one unique unit. And in all them, we are studying the insects, looking at pollinators, natural enemies, other beneficials, all different group of insects, and even pests, because we want to understand what is the real impact of these multifunctional areas just in the pest pressure, and also in the case of the diseases. And we are looking at the crop in terms of yield and quality. But the important thing of this project is that we are not considering only the surface. We are also considering the ground, because the soil is really important to keep our field for a long term. And in that case, we are looking in the soil biodiversity, studying all the different groups of invertebrates and microbiome, which is really important for soil health. And even we are looking through the physicochemical parameters of the soil: composition, erosion, infiltration, respiration, organic matter, carbon sequestration, nitrification. And this is just a summary of the total 38 parameters that we are studying. But also we are studying the connection between all of them, because at the end, this is a really quite complex project where we were looking all the entire agricultural ecosystem. And in that case, we are carrying out this project in collaboration with our external researchers and NGOs, which are driving and validate also the data. These collaborators are universities, museums, research centers, and all of them, they are really recognized well experts in the field of biodiversity and ecology. And their people, they publish hardly on these topics. And even we select them because when we presented our idea of LivinGro, they were really enthusiastic to join, because they think this kind of project studying all the ecosystem that could have a good impact in the conservation agriculture. Even we are collaborating with 35 growers. They are supporting and taking care of the different managements as they normally do without any influence. And even Syngenta, with the different areas as crop protection, business sustainability, stewardship, environmental safety, or global public policy, is supporting this project. In all our trials, we are dividing the field in 3 different treatments. The treatment number 1, as you can see in the picture below, it's a non-crop area. It could be a natural forest, or it could be an abandoned crop. That means a non-productive area. And then we have the treatment number 2 and treatment number 3, that they are a crop area where the growers are applying their normal application program. But in the treatment number 2, we are not implementing any multifunctional area, so it's our control. And then we have the treatment number 3, that it's where we are implementing these multifunctional areas. Also, we are working with different kind of fields, just having small ones with surrounding vegetation, like that one, or even big ones. For example, that one with 650 hectares only of stone fruits belonging to different species and varieties, but without surrounding vegetation. And even we are working in different kind of management practices. As in the case of the vertical crop, as you can see in the left, we are working part that you have this open field of grapes. But in some cases, growers are just using this plastic roof in the top when it's covered because they protect the fruits and the trees against the climate conditions during certain point of the season. And in the case of the row crops, we are developing two different strategies in our trials. In some of them, we are using cover crops in the intercropping time. And in other ones, and with all of these kind of different management practices, we'll be able to generate data and understand what are the good practices and what is the impact on biodiversity, but also we'll generate data to understand this conservation or regenerative agriculture. But talking about data, when do we expect this data? So this project was already launched or started last year in vertical crops. And at the beginning of this year, we got the first preliminary results, expecting to get the final ones around 23-24. And in the case of the row crops, we started 1 month ago, and we expect to have the final results by 2024-2025. So now you are introduced in this LivinGro project. And I would like to share with you from one of our pilots, where you can see this is a stone fruit field, where you have the different lines of stone fruits, and also these light greens, yes, it's our area of multifunctional areas. So what do you think? Do you think there might be some effect using these biodiversity measures? Yes or not? What do you think? So let's see what Google say. And please keep attention in the center of this video. So now we are 10 kilometers far away. Do you think there are some changes? We think that yes, and that a relative small measure can have a huge impact. So thank you very much and welcome to the LivinGro project.
Thank you very much, Javier. Insects is really in a national crisis, especially in Europe, and we need to adapt our farming systems to improve the populations of insects because they are really important in the whole cropping system and also for nature. It is interesting to hear about your research, and we are looking forward to hear more about it in the coming years. Yes. So thank you one more time. Now we have some time for discussion, debate, and we also have some questions. And we have questions especially to the first speech, Mr. Jumshudov, about raised seedbed. I think it is Jussi Knaapi from Finland who asked, it says that in Germany it is also used raised bed systems. That was more a comment. We have another thing from Jussi. It was a surprise that no-till didn't show up in measurements. Would you think lesser evaporation in no-till would show up? Maybe you could tell some more about your question, Jussi. You're welcome.
So, as we have measured the evapotranspiration with the farm weather station, we have already noticed that there is a considerable difference between if you have open culture or inversion, or you have vegetation or no-till, etc., etc. So I think the evapotranspiration is so big factor that it should show up also in soil moisture results. And this is an interesting point because we need to save water.
Yes, Water is important, especially in some geographical regions. But I could ask you, in Northern Europe, water can also be a problem for no-till because it can delay the drilling time. Have you seen that also?
Actually, we've been pretty happy with the results regarding the sowing date in spring cereals. If we have had problems, they are always related to too low cutting height on compound and too much loose straw. So every time we forget to cut high, and every time we don't have proper straw distribution, etc., those are the problems. If everything goes right, we have no issues in sowing date, not at all. And in most cases, like our trial site, right now when we already have very hot weather here also, we have cracks which are 2-3 centimeter wide already on plow culture because we have the plow pan and it will do the problem because it will dry up fast or it will stop the water infiltration. Either way, it's a problem. And in no-till, we don't see this kind of a clay soil cracking or it's shrinking. It's shrinking so heavily that if you don't see it on your own field, you would be surprised. It's really, I mean, like you Danes, you are in a good position with your better soils that they are not so crack prone or shrinking prone. I don't know how it is in Switzerland, for example.
Yeah, it's interesting to hear. We see the same thing here, but also interesting to hear that you say that cutting high stubble leaves less straw on the surface, and it can help for the drilling in the spring. It's a really interesting point of view. Yeah.
It is very important because we continuously see on our no-till, Finnish no-till conservation agriculture surroundings that whenever people are complaining about that this doesn't work, almost for certain there are these issues of management. And the best cases are just very, very, very promising. And so you have extremely happy people, no-tillers, and the ones who hesitate to go all the way, and they kind of think that I need to do something between, and then they start to do mixed farming, and actually they are losing things they just tried to achieve. So it is a little bit problematic.
It was a comment from you about Germany earlier.
Oh yeah. In Germany, I can't remember the name. Jana Eppelein must know her. There's a company, this company, and they actually do a raised bed system, and they apply that to cereals and vegetables and all. It's like a potato ridges, but they are a little bit wider, a little bit lower or shallower. I can't remember the name of the manufacturer, but they exist. I've been visiting their factory and their fields, and they say that it's way better in Germany because winter are cold. Well, they don't know how our winters are, but anyway, and they seem to be very happy with the system. It's a minority. It's a niche system for sure. I can send a link later on, but we were really interested to this because on our soils, if we don't have a proper topography, we might get rain events or snow melting events whatsoever, also this summer. When the topography of the surface is not okay, we get ponding of water and we get anaerobic zones and all these things. And the raised bed system actually mitigates these issues already, and they give a lot of benefits. It's demanding, of course, but anyway.
I forgot my microphone. Thank you very much. It's really interesting. We have a question here from Deogracias Negotio, I think, if I pronounce it right. It is actually more about cover crops. And it is said that in Tanzania, farmers are selecting cover crops for covering their soil, and also believe that it adds a lot of nutrients to the soil and cover the soil very well. But the question is now farmers is asking, is there any mechanisms or treatment for making the two cover crops edible for human being or for livestock feeding? Anybody has a comment or answer for that? Much about the growing season and how fast it could grow, but in Europe it is more and more introduced to grass the cover crops late in the season when the growth has stopped in the autumn. To put sheep or cattle into the cover crops and use it as fodder, and then the nutrients are released faster and more efficiently by the animals. I don't know if that could help. I think that would be a good solution, also in Africa. We have a question here.
If I may comment, we have had some experiences and experiments of cover crops in early days, over 10 years ago. Not very advanced, but we did measure the relation of nitrate or ammonium nitrate by keeping the ground green. We could minimize the measurements by researchers, and even that the cover crop was quite modest. We were gladly surprised how big an influence they can have, even that they clearly they were not really a heavy cover crop. They were under summer, and then they, after combining, we let them grow, obvious. So the ammonia side remains nicely in the soil, and the nitrates is less. And as we all know how the nitrate reacts, goes to the waterways, all that stuff, it was very nice results. And so I'm really happy if the Common Agricultural Policy will actually promote cover crops and non-bare surface over the winter. So I gladly take this if it just will get enough support and so.
Thank you, Jussi. Nice to know that you have these results in Finland. I can supply that in Denmark we have some political regulations that we have to have some part of each farm area with cover crops, but we also get more results from cover crops mixed with legumes, and actually they can also hold both nitrate and ammonia very well, even down to 2 meter depth. So it's a very important part of a successful conservation agriculture system. We have a question to you, Daria. It is asked, is it possible to use moldboard plow as CA implement? Because moldboard plow turns soil layers. I cannot understand the question, because if you use the moldboard plow, it is not a conservation agriculture. Maybe Nelson McCain can supply more about the question. But Daria, you have the moldboard plots in Oberager to measure and to compare to.
Exactly, yeah. So we have this plot the comparison to the no-till soil right next to each other. And well, this comparison over 20 years on the Everacker, it actually didn't really show differences between the two differently managed soils, as you saw in the presentation. So that's not true. Of course, it showed differences, but the differences were not systematic. And I found something that you said, Jussi, before really interesting about these mistakes or whatever small differences in management that have a huge impact on water. So this is exactly also what we thought. The problem was that we didn't really have detailed data about, for example, if the grass right around the measurement instrument was mown or if it was not mown. And obviously this would influence soil moisture suction. And I really think that if we would have had more details about this micromanagement thing, maybe we could have some systematic patterns. It was really hard to see also after we knew now harvest has happened, but we didn't really know what happened to the soil afterwards. How did it look like? What was left there on the soil and what was taken away? So yeah, I really want to stress this again. So if we want to do really the long-term measurements about soil moisture suction or soil humidity in general, we should definitely keep an eye on these details that maybe seem small, but they could make a huge difference.
Thank you very much, Daria. We have a question from Janne Aalborg Nielsen from Segis in Denmark. It is to Jussi. What are your experiences with Solvita and microbiometer? Can you tell a little about that, and will you recommend the method? We are also trying Solvita and microbiometer in Denmark. Oh, Jussi, you are muted.
Yeah, but not now anymore. Okay, I'm really pleased with both. Combine all the soil health measures what we do always to these soil scanning maps, so that we try to find high organic content plots and also high or low EC values, so that we kind of know where we take a sample, and we put that on the coordinate maps. Solvita Health Suite is brilliant because it gives you the idea of organically bound nitrogen at spring or before sow date, and this carbon dioxide breathing or the soil carbon dioxide burst. Absolutely, they go hand in hand with other kind of a thinking what we have about soil health and productivity. This summer, we are comparing these numbers to those meteorological weather station, those light chamber fluxes. So we are more knowledgeable of that later this year or next year. Microbiometer is kind of a little bit novel. You first think that can this be true, because it really gives you immediate estimate of bacteria and fungi. But so far I've been using that for 3 years, and it clearly is logical to my thinking. Wherever you have a good plant diversity, good rooting, all these things, you get high numbers. But then you can also be kind of a careless, like every measurement needs to be taken very, very carefully. And the thing is that you need to take the sample, I think, the microbiometer sample at the same depth and as close to the rooting zones, the rhizosphere, on each measurements. Because if you go more far away from the rooting on one plot and closer to the root zone, the active zones, another plot, you get different results. But so far, I like those two measurements, because as advisors, when we go to fields and farmers' farms, everybody wants to get results very soon. And these are, in that perspective very good, because even that we are not claiming that they are fully professional in the way as we do like DNA screening or whatsoever. It gives you levels of things that you can compare. You always need to compare two things. So then if you compare two things at the same time, you get a comparison. And even that the figures might be not absolutely right, you get the levels. This one seems to be better than this one. So I'm truly happy with both of these. Yes.
Thank you. It's very interesting to get these instruments to monitor what is going on, and it also interacts very well with the presentation of Rachid Moussadek from Morocco, measuring higher enzymatic activity. And I remember yesterday there was also some trials that showed that activity was much higher in no-till soil than plowed soil. So soil is really very complex, and a lot of invisible biodiversity is going on down there. So interesting. We have a question. It is to Javier Peris. It says, congratulations for the presentation and for the project. It's good to see that soil biodiversity is getting traction. The question is, in row crops, are you following conservation agriculture principles? That means rotation, soil coverage, and minimum soil disturbance.
So, first of all, congratulations. It's a pleasure that all the audience like the project. And in that case, related to the question, we can say that all our growers are using the good farming practices. And in the case of conservation agricultural practices, 90% of them, they are using soil coverage, rotation, minimum soil disturbance. But the other 10, unfortunately not now. But this is also good because this is a project, and we want to compare what happened when you are using one management, another kind of management, and this is going to generate data. And with this data, we'll be able to say later, okay, we need to follow that way, the other way, because at the end, what we miss, and we are here all, is we need data. And this is the important thing of the project. So having the 100% conservation agricultural practices already done, it's useful, but just having some of them that they are not following this, it's even more useful.
Thank you very much, Javier. It's interesting. We will follow you. Okay, time is running out. It is 12:30, and we have to follow the program. I would say thank you very much for your presentations and your speeches. It has been really informative information from your trials and research, and we could have a much longer discussion. That is the price we have to pay for the COVID-19 situation. It could be fun to meet you all in physical and have a talk after the meetings, but we will have to do like this, and hopefully the world will be more normal and we can meet in the future. And thank you for all listeners to this session here. And have a good day and a good program further on. Bye-bye.
Thank you. Bye-bye.
Thank you.